Microsoft Fabric Power BI Fundamentals, the complete guide to turning data into trusted business insights. Hello and welcome. In this video, we are going to walk through Microsoft Fabric Power BI Fundamentals from the ground up. Power BI is Microsoft's business analytics platform for turning data into actionable insights by connecting, preparing, modeling, visualizing, and sharing data across an organization. In Microsoft Fabric, Power BI is one of the core workloads in a broader end-to-end analytics platform that also includes OneLake, data integration, data engineering, data warehousing, real-time intelligence, governance, and AI-assisted experiences. The goal of this session is to help you understand what Power BI is and how its main building blocks work together in a modern Fabric analytics environment. Power BI helps organizations turn data into actionable insights by combining data connectivity, transformation, modeling, reporting, dashboards, apps, and sharing capabilities. It supports different types of users, including business users who consume reports, report creators who build models and reports, administrators who manage governance, and developers who embed or extend analytics. A business user may open an app or dashboard to monitor performance, while a report creator may use Power BI Desktop to build a semantic model and interactive report. This flexibility is one reason Power BI is used across areas such as finance, sales, operations, healthcare, education, and public sector reporting. At its core, Power BI is about making data understandable, interactive, and useful for decision making. Microsoft Fabric expands the Power BI experience by bringing multiple analytics workloads into one unified platform. Fabric includes capabilities such as OneLake, Dataflows Gen 2, lakehouses, warehouses, notebooks, pipelines, real-time intelligence, governance, and Power BI reporting. For Power BI users, this means they can continue using familiar reports, dashboards, workspaces, apps, and the Power BI service while gaining access to broader data platform capabilities. Existing Power BI content and workspaces do not need to be migrated simply because Fabric is introduced. Instead, Fabric adds new possibilities around unified storage, shared security, faster data access, and deeper integration across the analytics lifecycle. OneLake is an important Fabric concept because it provides a unified data lake for all Fabric workloads. Instead of creating many disconnected copies of data across different tools, Fabric is designed so data can be stored centrally and reused by multiple experiences. Power BI can take advantage of this architecture through direct lake mode, which allows semantic models to query data in OneLake without traditional import or caching. This is especially useful for large-scale analytic scenarios where performance, freshness, and data consistency matter. In simple terms, OneLake helps create one logical place for organizational data, while Power BI helps people understand and act on that data. Power BI has two main components, Power BI Desktop and the Power BI Service. Power BI Desktop is the Windows application mainly used to connect to data, transform it with Power Query, create semantic models, define relationships and DAX calculations, build reports, and prepare content for publishing. The Power BI Service is the cloud platform where reports, dashboards, apps, semantic models, workspaces, refresh schedules, sharing, collaboration, and governance are managed. Power BI Mobile allows users to view and interact with reports and dashboards on phones and tablets. Together, these experiences support the full journey from report creation to secure business consumption. A typical Power BI workflow starts with connecting to data sources such as Excel files, SQL databases, cloud services, web data, Fabric lakehouses, warehouses, or other enterprise systems. After connecting, the data is usually cleaned and transformed so that columns, data types, filters, and transformation logic are ready for analysis. Next, the report creator builds a semantic model by defining relationships, measures, hierarchies, and business logic. After that, visuals and report pages are created to communicate insights clearly and interactively. Finally, the report is published to the Power BI service where it can be shared, refreshed, secured, packaged into apps, or pinned to dashboards for broader business consumption. Power Query is the data transformation and preparation layer used in Power BI Desktop, Dataflows, and other Microsoft Fabric experiences. It helps users clean, filter, combine, reshape, and standardize data before it enters the semantic model. Common Power Query tasks include removing unnecessary columns, changing data types, filtering rows, merging tables, appending data sets, pivoting or unpivoting data, and creating repeatable transformation steps during refresh. This process is important because poor quality data leads to unreliable analytics, regardless of how visually appealing the reports may appear. A strong Power BI solution usually begins with clean, consistent, and trustworthy data preparation. The semantic model is one of the most important concepts in Power BI. It is the structured data layer that reports, dashboards, Q&A experiences, and other analytics tools use for analysis. A semantic model can include tables, relationships, measures, hierarchies, calculations, security rules, and metadata that make raw data easier to understand and analyze. Instead of every report creator redefining calculations independently, the semantic model creates a centralized and reusable version of business logic. This improves consistency because users across the organization can analyze the same trusted measures, dimensions, and definitions. Data modeling is the process of organizing data so it answers business questions accurately, efficiently, and consistently. A common modeling approach in Power BI is the STAR schema, where a central fact table stores measurable business events such as sales, transactions, or quantities, while surrounding dimension tables describe those events using attributes like date, product, customer, employee, or geography. This structure simplifies filtering and analysis because users can explore facts through descriptive dimensions. It also improves performance, scalability, and usability compared with flat, duplicated, or poorly structured data sets. Good data modeling is one of the key differences between a simple visualization and a reliable enterprise analytics solution. Measures or calculations used in Power BI to summarize and analyze data dynamically. Examples include total sales, average profit, year-to-date revenue, growth percentage, profit margin, and customer count. Measures are typically written using DAX, which stands for Data Analysis Expressions and serves as Power BI's analytical formula language. Unlike static calculated values, measures automatically respond to filters, slicers, report context, and user interactions. This means a single measure can return different results depending on the selected region, date range, product category, customer segment, or other filtering conditions applied by the viewer. Power BI reports are interactive collections of visuals, text, filters, and pages built from a semantic model. A report can contain a single page or multiple pages depending on the complexity of the business scenario. Users can filter, slice, cross-highlight, drill down, drill through, bookmark views, add comments, subscribe to updates, and explore details based on their permissions. Reports are ideal when users need to analyze data from multiple perspectives rather than simply monitor a few top-level metrics. A well-designed report does more than display charts. It guides users through a meaningful business story and helps them make informed decisions. Dashboards are different from reports because they are single-page canvases made up of tiles. A tile is typically a visual pinned from a report, although dashboards can also include images, text, streaming data, or content from other sources. Dashboards are designed for monitoring important metrics at a glance, such as sales performance, operational health, service status, or executive KPIs. Unlike reports, dashboards do not provide the same level of deep filtering and multi-page exploration. They function more like a monitoring console that brings together critical signals in one consolidated view. Reports and dashboards are often confused, but they serve different purposes in Power BI. A report typically connects to a semantic model and provides detailed, interactive analysis across one or more pages. A dashboard, on the other hand, can combine visuals from multiple reports, semantic models, or datasets into a single summary view. Reports are better suited for detailed exploration and analysis, while dashboards are optimized for quick awareness, monitoring, and executive tracking. Understanding this distinction helps organizations deliver the right experience to the right audience. Visualizations are the charts, tables, maps, KPIs, cards, matrices, and other visual elements used to communicate insights from data. Power BI includes many built-in visuals and also supports custom visuals from Microsoft App Source. Visuals are interactive, meaning that selecting one data point can filter or highlight related information in other visuals on the same report page. This creates an exploratory analytics experience where users can move from a high-level trend into detailed causes, patterns, or exceptions. Effective visual design should improve clarity and understanding rather than simply making reports look crowded or decorative. Filters and slicers are essential for interactivity in Power BI reports. Filters can be applied at the visual, page, report, or semantic model level, while slicers provide users with an on-page way to narrow data using fields such as date, region, product, or category. Users can also sort visuals, drill into hierarchies, view tooltips, and inspect underlying data depending on permissions and report settings. These interactive capabilities help users answer follow-up business questions without requiring separate reports for every scenario. A strong report design gives viewers enough flexibility to explore data while still keeping the experience intuitive, guided, and easy to understand. Power BI Q&A allows users to ask natural language questions about their data and receive answers automatically as visuals. For example, a user might ask for total profit by country or average sales by product, and Power BI can return a chart, table, card. This capability is valuable because it lowers the barrier for users who may not know how to build visuals or write queries manually. Q&A works best when the semantic model uses clear business-friendly naming, accurate relationships, and well-defined measures. Natural language analytics can greatly improve accessibility, but its effectiveness still depends on the quality and structure of the underlying semantic model. Copilot and AI capabilities add another layer of assistance to Power BI and Microsoft Fabric. When enabled by the organization, Copilot can help users create reports, summarize insights, generate narrative explanations, suggest visualizations, assist with DAX calculations, and explore data using conversational prompts. These features are designed to accelerate productivity and simplify analysis rather than replace human expertise or decision making. Users still need to validate outputs, confirm business definitions, and review whether generated insights or visuals are accurate and appropriate. AI delivers the greatest value when it operates on trusted, well-modeled, secure, and properly governed data. Workspaces are collaborative containers where Power BI and Microsoft Fabric content is stored, organized, secured, and managed. Depending on the Fabric environment, a workspace can contain reports, dashboards, semantic models, apps, lakehouses, warehouses, notebooks, data flows, pipelines, and other Fabric items. Workspace roles such as admin, member, contributor, and viewer determine what actions users are allowed to perform. For example, a viewer may only consume reports, while a contributor can create, edit, and publish content. Workspaces are essential for team collaboration, content lifecycle management, security, and enterprise governance. My workspace is a personal workspace automatically provided to each Power BI user. It is useful for learning, experimenting, testing ideas, and building content intended for individual use. However, production-grade analytics content should generally be stored in shared workspaces because they support collaboration, governance, deployment processes, role-based security, and app distribution. My workspace is not intended to serve as the primary location for enterprise reporting that multiple teams or business processes depend on. A mature Power BI environment typically separates personal experimentation from centrally managed organizational analytics solutions. Power BI apps are curated collections of reports, dashboards, semantic models, and related content distributed to business users. Apps are useful when teams want to provide a polished and controlled analytics experience to a broader audience. Instead of requiring users to navigate through a workspace that may contain development or intermediate items, the app exposes only approved and relevant content. App permissions can also be managed separately from workspace permissions, helping administrators simplify access management and governance. For many business users, apps become the primary way to access official dashboards, reports, and trusted organizational insights. Power BI content can be shared in several ways, including direct report sharing, workspace access, app distribution, email links, Microsoft Teams integration, SharePoint embedding, and mobile access. What a user can do with shared content depends on licensing, workspace roles, capacity type, and item level permissions. Some users may only view and interact with reports, while others may edit content, reshare reports, build new reports from semantic models, or manage permissions. This security and permission model is important because analytic solutions must balance accessibility with governance and control. Power BI is designed to support collaboration while protecting sensitive business data and limiting unnecessary access. Licensing is a major part of Power BI and Microsoft Fabric fundamentals because it determines how users create, share, collaborate on, and consume analytics content. The main user-based licenses include Microsoft Fabric Free, Power BI Pro, and Power BI Premium per user. A free user can create content for personal use in my workspace and may consume shared content when it is hosted in supported premium or fabric capacity environments. Power BI Pro enables publishing, sharing, collaboration, and participation in standard workspaces. Premium per user provides access to many advanced premium features on a per user basis, but it is different from purchasing dedicated fabric or premium capacity for the organization. Capacity is different from a per user license because it provides dedicated or shared compute resources that power workloads across Power BI and Microsoft Fabric. Microsoft Fabric capacities use FSQs, while traditional Power BI premium capacities historically used PSQs. Capacity influences scale, performance, workload availability, refresh capabilities, and whether free users can consume Power BI content. For example, when Power BI content is hosted in supported Fabric or Premium capacity, users with free licenses may be able to view reports if they also have the correct permissions. Smaller capacities or shared environments may still require users to have Power BI Pro, Premium per user, or trial licensing for collaboration and content consumption. Fabric licensing introduces an important distinction between Power BI workloads and broader Fabric workloads. A Microsoft Fabric free license may allow users to access Fabric experiences and create certain non-Power BI Fabric items in capacity-backed workspaces, depending on tenant settings and organizational configuration. However, creating, publishing, and broadly sharing Power BI content outside my workspace generally still requires Power BI Pro, Premium per user, or an eligible trial license. Premium per user enables advanced Power BI capabilities for individually licensed users, but it does not itself provide dedicated Fabric capacity. To run Fabric workloads such as lakehouses, warehouses, notebooks, pipelines, and large-scale analytics scenarios, organizations typically require Fabric capacity or trial capacity resources. Administrators play a critical role in managing Power BI and Microsoft Fabric adoption across the organization. They assign licenses, configure tenant settings, manage self-service sign-up and purchase options, enable or restrict features, and monitor platform usage and performance. Administrators also govern external sharing, workspace management, capacity assignment, data protection policies, audit logging, sensitivity labels, and security settings. This administrative layer is essential because Power BI and Fabric often contain sensitive, regulated, or business-critical information. A successful analytics environment requires not only strong report development skills, but also careful governance, compliance, security, and operational planning. Security in Power BI includes workspace roles, item permissions, tenant settings, sensitivity labels, audit logging, and row-level security. Row-level security allows the same report or semantic model to display different data to different users based on rules such as region, department, business unit, or manager responsibility. Build permission controls whether users can create new reports from a semantic model, connect through Analyze in Excel, or reuse the data for additional analytics. These controls help organizations balance self-service analytics with governance and data protection requirements. The overall goal is to provide users with the insights they need while preventing unauthorized access to sensitive information. Dataflows provide reusable and centralized data preparation in the Power BI service and Microsoft Fabric environment. Instead of repeating the same Power Query transformations across many separate reports or semantic models, teams can create shared data flows that prepare data once and reuse it across multiple solutions. Dataflows Gen 2 in Fabric extends this approach by integrating data preparation with modern Fabric destinations such as lakehouses and warehouses. This architecture is especially useful when many reports depend on the same standardized and trusted data. Centralized data flows improve consistency, simplify maintenance, reduce duplication, and support more scalable enterprise data preparation practices. Lakehouses are a key part of the Microsoft Fabric data platform and provide centralized storage for structured and semi-structured data used in analytics. In common Fabric workflows, users create a lakehouse, ingest and transform data using Dataflows Gen 2 or pipelines, and then build semantic models directly from lakehouse tables. This connects the data engineering side of Fabric with the reporting and analytics capabilities of Power BI. Rather than treating reporting as an isolated final step, Fabric enables organizations to move from ingestion to transformation, modeling, and visualization within one integrated platform. This represents a major shift from older business intelligence architectures, where data engineering and reporting tools were often disconnected. Pipelines in Microsoft Fabric help orchestrate and automate data movement, refresh processes, and operational workflows. A pipeline can execute data flows, refresh semantic models, coordinate transformations, schedule recurring operations, and trigger notifications or failure handling activities when problems occur. For example, a pipeline may send an email alert if a refresh process fails or data does not load successfully. This operational capability is important because analytics environments must remain current, reliable, and monitored. If refreshes fail silently, users may unknowingly make decisions based on outdated or incomplete information. Pipeline orchestration adds automation, governance, and operational discipline to the analytics lifecycle. Direct Lake is an important capability in Power BI and Microsoft Fabric because it allows semantic models to query data stored in OneLake with very high performance while reducing the need for imported copies of data. Traditional import mode can provide fast analytics performance but requires scheduled refreshes and duplicated storage, while Direct Query provides live access to data sources but can introduce performance limitations depending on the backend system. Direct Lake is designed to combine the scalability of lake-based storage with the responsiveness expected from modern business intelligence solutions. This capability is especially valuable for organizations building large-scale analytic solutions on Fabric lakehouses or warehouses. Direct Lake represents a more modern and integrated approach to enterprise-scale Power BI architecture. Power BI also supports Direct Query, Live Connection Composite Model, and Direct Lake scenarios for enterprise analytics. Direct Query allows reports and semantic models to query the underlying source system at runtime instead of importing all data into Power BI storage. This approach can be useful when data must remain in the source system, when near real-time access is required, or when datasets are extremely large. However, Direct Query requires careful design because report performance depends heavily on the source system, semantic model structure, query optimization, and report complexity. Choosing between import mode, Direct Query, composite models, and Direct Lake should be based on factors such as data volume, freshness requirements, latency expectations, governance policies, and overall user experience goals. Power BI Desktop is updated frequently, and organizations are encouraged to stay on the latest supported release. Microsoft documentation emphasizes that only the latest version is fully supported for troubleshooting and support scenarios. Installing Power BI Desktop from the Microsoft Store can simplify updates because Windows can automatically keep the application current in the background. Organizations can also deploy Power BI Desktop centrally using executable installers, administrative deployment methods, and command line installation parameters. Staying current is important because Microsoft regularly introduces new modeling capabilities, reporting features, security enhancements, data connectors, AI improvements, and performance optimizations. Power BI supports many report consumption experiences beyond the standard web browser. Users can access reports and dashboards through mobile applications, receive scheduled email subscriptions, interact with embedded analytics in Microsoft Teams or SharePoint, and sometimes consume reports directly from line of business applications. Mobile optimized layouts help users stay connected to business insights while working remotely or in operational environments. Features such as alerts, notifications, QR codes, and real-time dashboards can connect analytics directly to day-to-day business operations. This flexibility makes Power BI useful not only for traditional office reporting, but also for executive decision-making, operational monitoring, and frontline business scenarios. Paginated reports are designed for structured, print-ready, pixel-perfect reporting scenarios. Unlike highly interactive Power BI reports, paginated reports focus on precise layouts that can span many pages and maintain consistent formatting during printing or exporting. Common use cases include invoices, financial statements, operational listings, regulatory documents, compliance reports, and detailed tabular exports. Power BI Report Builder is the primary tool used to create paginated reports. This reporting capability complements interactive dashboards and analytical reports by supporting business processes that still require formal, structured, and printable documents. Power BI Report Server provides an on-premises reporting platform for organizations that cannot fully adopt cloud-based analytics solutions. It allows reports, KPIs, and related reporting content to be hosted within local infrastructure environments supporting hybrid architectures where some analytics workloads remain on-premises while others move to Microsoft Fabric or the Power BI service. This can be important for organizations with regulatory, network, security, or migration constraints that limit cloud adoption. However, the broader direction of innovation across Power BI and Microsoft Fabric is strongly focused on cloud-native capabilities, AI integration, OneLake, and unified analytics experiences. Organizations should evaluate their long-term reporting and governance needs carefully when balancing on-premises and cloud analytics strategies. Excel integration is an important part of the Power BI ecosystem because many organizations already rely heavily on spreadsheets for analysis and reporting. Power BI can use Excel workbooks as data sources, and users can also connect Excel directly to Power BI semantic models through live connections when permissions allow. This helps bridge familiar spreadsheet-based workflows with governed enterprise analytics models. Instead of exporting static datasets and creating disconnected spreadsheet versions, users can analyze trusted Power BI data directly within Excel. This combination is valuable because it provides both the flexibility of Excel and the consistency of centralized business definitions and governed semantic models. Power BI includes search, browsing, favorites, recents, and shared content experiences that help users locate reports, dashboards, apps, semantic models, and workspaces. As organizations expand their analytics environments, content discovery becomes increasingly important. Users can search by report name, owner, workspace, keywords, or related business terms, and they can filter or sort content to narrow results. Areas such as shared with me, favorites, and apps are especially important for business users who primarily consume analytics content created by others. Strong content organization, naming standards, and governance practices help prevent Power BI environments from becoming cluttered, duplicated, or difficult to navigate. Business users can safely interact with Power BI reports and dashboards without damaging the original shared content or semantic model. Depending on permissions, users may filter, slice, drill down, export data, subscribe to reports, add comments, personalize visuals, or save personal bookmarks. These interactions typically affect only the individual user's session or personal view and do not modify the underlying published report for everyone else. Users can often reset filters, slicers, and personalize changes back to the default state when needed. This safe self-service exploration model encourages users to investigate and learn from data without fear of accidentally breaking enterprise reporting solutions. Power BI supports alerts, subscriptions, and monitoring capabilities that help users stay informed about important business changes. Email subscriptions can deliver report pages, dashboards, or app content to users on a scheduled basis when licensing, permissions, and tenant settings allow. Data alerts can notify users when dashboard tile values cross defined thresholds or conditions. These capabilities are valuable when executives, managers, or operational teams do not want to manually monitor dashboards throughout the day. Instead, Power BI can proactively surface significant changes, helping organizations respond faster to business events, risks, or opportunities. Real-time analytics and streaming capabilities enable Power BI dashboards and reports to update as new data arrives. These scenarios may involve IoT sensors, application telemetry, operational events, manufacturing systems, financial activity, website usage metrics, or other time-sensitive business signals. Real-time dashboards are especially useful when waiting for scheduled refresh intervals would be too slow for operational decision-making. However, real-time analytic solutions should be designed carefully so users clearly understand which information is live, which data refreshes periodically, and which content represents historical analysis. Clear labeling, governance, and user education help prevent confusion between streaming data, refreshed data, and historical reporting views. Power BI provides learning paths and capabilities for different roles and skill levels across the organization. A new Power BI user may begin with core concepts, such as installing Power BI Desktop, connecting to data, creating simple visuals, building reports, and publishing content to the Power BI service. Business users often focus more on signing in, navigating reports and dashboards, finding shared content, using filters and slicers, subscribing to updates, and interacting with Copilot or Q&A features. Data analysts typically go deeper into data connectivity, Power Query transformations, relationships, DAX calculations, semantic modeling, and performance optimization. Administrators focus on licensing, tenant configuration, governance, security, capacity management, monitoring, and organizational adoption practices. Advanced Power BI report creators can use features such as bookmarks, buttons, drill-through pages, custom tooltips, conditional formatting, field parameters, custom visuals, selection pans, and performance analysis tools. These capabilities help create more guided, interactive, and polished analytics experiences for users. However, advanced design should always support the business objective rather than distract from it. Reports that contain too many visuals, excessive interactions, unclear navigation, or unnecessary complexity can become difficult to understand and maintain. The most effective Power BI reports balance interactivity, usability, performance, simplicity, accessibility, and storytelling. Developers can extend Power BI through embedding, REST APIs, automation, custom visuals, and integration with broader Microsoft and third-party platforms. Embedded analytics allows Power BI reports and dashboards to appear inside internal business applications, customer-facing portals, SaaS platforms, or Microsoft 365 experiences. Licensing and architecture considerations vary depending on whether the scenario uses user-owns data or app-owns data models. Developers must also address authentication, authorization, role-level security, tenant settings, scalability, and performance optimization. These capabilities position Power BI not only as a reporting solution, but also as a platform for integrating analytics directly into applications and business workflows. Governance becomes increasingly important as Power BI and Microsoft Fabric adoption grows across an organization. Without effective governance, environments can become fragmented with duplicate reports, conflicting business metrics, unmanaged exports, unclear ownership, inconsistent naming standards, and weak security controls. Strong governance defines who can create workspaces, who can certify or endorse semantic models, how sensitive data is classified, how sharing is controlled, and how usage and compliance are monitored. Governance should not prevent innovation or self-service analytics, but instead provide guardrails that support trusted and scalable analytics practices. The most successful Power BI environments combine user flexibility with enterprise-grade governance, security, and operational standards. A complete Power BI and Microsoft Fabric solution connects many technologies and processes into one end-to-end analytics lifecycle. Data may originate from files, databases, SaaS applications, APIs, streaming systems, or operational platforms, and then move into Fabric through pipelines, Dataflows Gen 2, shortcuts, or other ingestion methods. The data may be stored centrally in OneLake and organized through lakehouses, warehouses, or other Fabric storage structures. From there, semantic models are created and visualized through Power BI reports, dashboards, apps, and embedded analytics experiences. Users can consume insights through browsers, Microsoft Teams, SharePoint, mobile devices, email subscriptions, or integrated business applications. This connected lifecycle is one of the main reasons Microsoft Fabric and Power BI are powerful together as a unified analytics platform. To conclude, Microsoft Fabric and Power BI fundamentals are about much more than learning where buttons and menus are located. They are about understanding how raw data becomes trusted business insight through connection, transformation, modeling, visualization, sharing, security, governance, and operational management. Power BI provides the reporting, semantic modeling, and decision-making layer, while Microsoft Fabric expands the ecosystem into unified storage, data engineering, orchestration, AI-assisted analytics, and enterprise-scale data management. If you understand semantic models, reports, dashboards, workspaces, apps, licenses, capacities, governance, and Fabric integration concepts, you have a strong foundation for building real-world analytic solutions. Thank you for taking the time to explore this topic, and I hope this guide helps you confidently begin or strengthen your Microsoft Fabric and Power BI journey.